Okay, I really want to talk about these default values for a function as well, because that's important and mostly needed. The default value is a value of the input variable that you assign while you are defining a function. And if the value is, for example, if you call this f with, let's say, the input value 3, then 3 will be copied in the sum and the print will be 3. But if you call this function without the input, then this value acts as if you have passed this. So this is the default value. If you do not supply the value, this is the value that is going to operate. And by the way, you can have multiple variables with default values, some variables with default values defined, some variables with default values not defined, and so on. So you can have this. One care must be taken here that the default value, when you actually define the function and you compile this function, actually you run the cell shift enter in Jupyter Notebook, at that very time this variable is assigned this value at that particular time. It is not assigned at the call time. So sum equals to 0 is already there when you actually press shift enter for a cell that contains this code. Now later on, if you pass a value, that value will be overwritten on sum. If you don't pass the value, the 0 will go on. It looks like very easy. But one care that I want to mention here that I haven't mentioned earlier. In Python, there are certain variables that are referenced rather than copied. I will discuss the referencing and the copying in detail in data structures, but let me just tell you one example. Let's say you defined a list. Let's say 1, 2, and 3. And then what you do, you copy this list into another variable, let's say L2. What will happen is, in the memory, this list in a particular way, this is not the exact view of the memory, I'm just showing you. Let's say this is the particular memory layout for which this L is pointing to. This L is labeled for that. L2 is also labeled for that, which means actually in memory, this is not the copy of the structure that is made. I mean, this is not like in variables, for example, if A is equal to 3 and B is equal to A will be a position in memory and B will be a separate position in memory. That is what a view of the memory in ordinary variables are. But there are certain variables in memory just for memory efficient and code efficiency and time. People have designed these data structures in a way that when you copy them, when you just assign a variable to another variable, the memory view doesn't change. It's another name for the same memory location. So what happens is, if you change any value in, let's say L2, at the 0th index, let's say you change that by -9, because it is the same view in memory, that changes -9. And now if you print the elements of L rather than L2, you will get the changed value. You will see the changed value, and that happens. Now, why that is important in terms of these default values here for a function? The reason is, if you are accepting a list, let's say the default is a list, and you're accepting a list and you are also defining some default value for the list, if that's your definition, let's say, then this default value is assigned at the very first time, and this L is really a local variable inside the memory. Now, once this cell is run, not the call time, so what called the compile time, when the cell is run, this L is assigned this, and that just happens once. Now if you call this list with some other list, let's say L2, let's say 2, 3, and 4, then if you call this L2 will go there, it will be copied in L, and everything is fine. But don't then expect the contents of L2 to stay in L, because L is this default values, they are assigned just once and they stay as it is every time you call the function. They don't change. They are not assigned at the call time, they are assigned at the compile time, and they stay fixed. So that care must be taken. I will show you that particular example in Jupyter Notebook shortly. This might be confusing right now because we have not seen lists in detail. But I just want to make this point. I just want to mention this because that's important difference with ordinary variables. That default value is just like a value, and if you don't supply a value, the default value just works. But with the variable that are reference type variables, you may expect something else, and the Python function behaves maybe differently, and that's because these default values, they are assigned at compile time. They are not, or compile time, actually this is not a compiled language. I should not use the word compiled again and again. Just think, when we define this function and we run the cell at that particular time, the default value is assigned, and the default value never changes. It stays fixed. Yeah. So, and I will show you that example. Why don't we move to Jupyter Notebook and see that example? Yeah. So, or why don't we do that in the next video? What do you think? This video? Okay, same video. Okay, let's go to Jupyter Notebook and see the default values. For example, let's see. Let's say we have define a function, let's say gg, and the default value s is equal to 4. Let's say that's a default value, and we want to print, let's say, s if available from the call time. If not available, then 4 will be printed. Now we print. Now right now we are going to print. Now we are going to press shift enter. At that time, s is assigned to 4. S has now value 4. It is assigned there. Now we call gg, let's say, and we call gg without input arguments. Now the 4 will be printed. If we call this gg with some input argument, let's say 56, now the 56 will be printed, no problem, everything is fine. Let's see about the lists. For example, let's say the list is, let's say 1 2 3, that's a list, and then L2 is simply, let's say L2 is L. Then what we do is we change the contents of L2. Let's say we change the very first value in L2 and we place that value as -9, and then we print L. Now you might be expecting that L is a different thing, L2 is a different thing. Because L and L2, they both are pointing to the same memory, the content through L2 actually changes the memory view, and L also changes, and that gives the result -9 in L. Well, the behavior that I want to show you is different in the default values when we talk about. For example, let's say we define a function ff, and it accepts a list, and the default value is empty list, or the default value is, let's say 1 2. That's the default value. Let's say if no list is passed, the default list is 1 2. Now in this particular scenario, if we just print, so for example, for I in list, print I, let's say we just print all the list, that's it. Now we will press shift enter, and at this time this L is assigned this value, and that's a default value that is not going to change. Now let's say we have an L2 that is simply, let's say 2 3 and 4, or let's say 12 3 and 4, and what we do is we call ff, and we just press shift enter. Now why not? We call ff without anything, so the default list is printed. If we call this ff with L2, the L2 will be printed. Now notice that this L2 actually is copied in this L because we supplied it. So L and L2, you may tend to think that L is now also pointing to L2. I mean, L has also the same contents as L2. So if next time, because of the behavior of these lists, because they are by reference, next time you might be thinking that because L2 is passed there, so L2 is copied in L in a memory view layout. So L has also the same data as L2, and next time if we call this function without input arguments, then L might be pointing out to L2 values, so 12, 3 and 4 might be printed. But that is not going to happen. The default values, they never change. Again, you'll be getting 1, 2. So the behavior of these reference type variables, that is different ordinarily, but when you do that in the default value structure, that might work in a different way. And the reason is you must know that these default values, they're assigned at the time when the function is created, not at the function when the function is called, and they are not going to change whatsoever. So that was about the default value. By the way, the default value was a simple concept. I guess I have made it too complicated by telling you lists and default values and the creation of these variables at what time and at the call time. I made this complicated, I guess. I shouldn't have told you the list values and all that stuff, but that's true. I mean, whatever I have told you is true. Maybe I have told you in a very complicated way, but it's true. Yeah. Okay. One more video on the functions, and then we will be practicing the functions in detail on Jupyter Notebook. So just bear one more video with me. Hope to see you in the next video.